there are two ways to make the logic for the player to jump. One of these ways is to use more or less what we've learned right now. Okay, we could do something like if input.getKey, and then we type up as a string, we can just type transform.position plus equals vector3.up, so it's a direction that is going to point upwards, multiplied by speed multiplied by time dot delta time. Okay, then we can save this, we can go to Unity, wait for the compilation to be complete, and if we press the up arrow, then we're going to make the player to move up. But then we would have to implement the logic to apply the gravity and make the player to move down all the time. Then we would have to worry about collisions. So instead of doing this, okay, instead of writing all of these logic, let's remove that. We can use something that's already implemented in Unity. Okay, we can use the physics system here. So it's going to make our lives much easier. So first of all, we need to add a floor here. Okay, in our hierarchy, we're going to right click, select 3D object and then cube. We want to rename this cube to floor. We want to set its position to be 0, 0, 0. And we want to change its scale so it resembles a floor. Okay, so it's going to be kind of a very thin sheet of paper. So I'm going to change the scale on X to 10, on Y to be 0.01, something very thin, and on Z to be 10. Okay, so we have a very simple floor in here. Okay, now let's make a quick test. If we get a player and move it up, and if we press the play button, notice that the player is just hovering there. Okay, it's not falling. Physics are not being applied. Let's bring the camera a bit closer just so we can see this better. Okay, so let's change its Z position to -6. Now let's try that again. Okay, so there we are. The player is there, but it's just flying around. It's not falling. This is happening because we specifically need to tell Unity that we want this game object to respect the laws of physics. We need to activate it. And we need to do this because, well, physics are they execute expensive operations. There are lots of calculations being done all the time, just as we were about to implement. Okay, so we need to be very sure of what we're doing. Now, we want to select the player game object. Here in the inspector, we click on Add Component, and in the search field, we're going to search for rigid body. Okay, and after that, we just click here on rigid body, and that should be enough to apply physics to this cube. Okay, we have a few properties here. We can see that we can set the mass, the drag. We can set if we use gravity, if you want to do collision detection, and things like this. Okay, and now that we have this, if we press the play button, just by adding this component, the cube now falls and stays on the floor. Okay, we can still move it to the left and to the right, but we need to work on the jumping logic. So how do we do this? We need to go back to our code. So instead of using input.getKeyUp, let's use input.getKeyDown, and we want to pass space as a parameter. Okay, and now that we are here, we need to apply what we call a force to the player. Okay, so imagine we have this cube here. To make the jump, we're going to kind of kick this player, this cube, upwards. We're going to apply one single force at one exact moment of time, so it's going to have its velocity changed to a vertical value. Okay, so to do this, we're going to need a variable here. We're going to type public float jumping force. Okay, so let's start by setting this to 10F. Okay, it's going to be 10 units. We're going to save this, and when getKeyDown is triggered, we're going to require to access this rigid body of the player. Okay, so right now we have this rigid body component, but we are in the player component, and we need to access the rigid body. To do this, we need to type here get component. We're going to type the lesser than and the greater than characters, and between them we're going to type rigid body. So we're going to get the rigid body component, and the important thing here is this is a method call. We're specifically telling what's the type of the component that we want to get here, and we open and close parentheses to call the method, and well, we don't pass any parameters in here. Now we use dot to access that rigid body, and we're going to call the method add force. Okay, so there are some signatures to add force. Okay, there are different ways. You can apply a vector 3, or you can specifically tell the x, y, and z values here. Okay, so the horizontal force that is going to be added is going to be 0. Okay, we don't want to make the player to move horizontally. The vertical value is going to be the jump force that we just declared. Okay, jumping force. And the third value is going to be 0 because we just want to make the player to be propelled upwards, right? And if we save this and go back to Unity, we wait for this compilation to be completed, and now if we press the play button, if we press space, the cube is being propelled upwards. However, the force is very little. Okay, so in other ways, if you were studying this in a different manner, you would have to go back to the player code, change the jumping force to another value, then play again, then spend minutes trying to find the perfect number. But as we're using Unity and we made the jumping force public, we can just change that while the game is running to other values like 100. And if I press space now, the player moves up a little bit more. Okay, well, it's not enough. Let's use 300. Okay, so this is a nice value. Okay, so we can make the player to move to the left and to the right and jump in the middle of this process. Okay, which is great. Okay, so we have this jumping force working as we expected. And notice that if this was get key, okay, so just get key, if we save this and go to Unity and try to play again, if you hold the space key, and even if you want to press, you are going to hold for a few milliseconds, you like it or not. Okay, so the force that would be added would be huge. Okay, so let's use 300 here. If I press space, the cube just vanished from the scene. Okay, I think there it is, it's falling now. Okay, so that happens if you do that. Okay, if you use just get key. So we're going to use get key down here. Let's save this jumping force at 300 so we don't have to set it again. Okay, and there is one more issue with this setup that we did with this input. Okay, even though it's on get key down, we can still release and press space again mid-air and make the player to kind of flap. Okay, this works for games like Flappy Birds, but we just want the player to jump once after they hit the floor again. Okay, so we're going to do a very simple collision check. Okay, so in the player, we're going to type void on collision enter. And between parentheses, we're going to type collision. We open and close curly braces. We do this because we're declaring the on collision enter method, and this is a specific name that Unity uses. We need to receive exactly one parameter, which is going to be collision, and we want to check if collision dot transform dot name equals to the string floor. That means we just hit the floor. So let's test that. We're going to type debug.log hit the floor. Okay, we do this because we want to check if the cube has hit the floor. So we save this, we go to Unity, wait one more time, and after this is completed, we press play. We have our cube, and once it hits the floor, we receive exactly one hit the floor message. If we press space, the player jumps. Once it hits the floor again, we receive another hit the floor message. So let's use that to our favor. Okay, so in player, we're going to type here private bool can jump equals to false. So we declare a boolean variable that is going to determine if the player is able to jump. Okay, it's boolean, so it's going to be either true or false. It's private, so other classes can access it, so that's internal, and it starts as false. Okay, and the jumping here is only going to happen if can jump is true. Okay, so this is what we're going to do. When we type that we want to check if space key is down, we also need to add another condition here. So the player can only jump if they press space and if this value here can jump is true. So we are going to type two AND characters. Okay, this is the operator for AND, and we're going to pass can jump. Okay, so we're saying that this conditional block is going to be executed if the left expression is going to be true and the right one is true. Both of them have to be true at the same time so this can be applied. And if the player hits the floor, we set can jump to be true. Okay, so we save this script. We move back to Unity and wait a little bit for this compilation to be ready. We press the play button. So we have the player false. We press space, and we actually have to, when we jump, okay, in the exact moment when we jump, we have to set can jump to be false. Okay, so here we set can jump to be false. Okay, so the flag is set to false, and then we have to fall again, and so we're able to jump again. Okay, so this time I press the play button one more time, and now if I press space multiple times, okay, I'm pressing several times here, but the player only jumps when they hit the floor. Okay, and well, we have a player that moves to the left and to the right. Okay, but what if we want to make this player to move differently? What if we want to make this player move like it was a cart? Okay, so we want to be able to hold the up key and make the player move toward a certain direction. This is very useful for racing games, but also for virtual reality games, okay, because you're always facing one direction, and if you want to make the player move in that specific direction, well, you need to understand where the player is pointing to and make it move in that direction, okay, and also make the player to rotate. So let's work on this logic in the next video. If we want to make our input react differently so it works for something that is a kind of a karting race game or a virtual reality experience, we need to understand one thing. Okay, so we have the player selected. We have three arrows coming out of the player, as we can see here in the scene window. We have one arrow that goes to the right, the red one, which is the horizontal axis, another one that goes vertically, which is the vertical axis, and another one that goes into the depth axis, okay, which is this blue arrow here. So if we want to make a player to move into that direction like it was a car, we need to get this arrow here. We need to get this vector. So to do this, we're going to work with the up key. So we're going to type here if input dot get key, and as a parameter we're going to pass up. Then we're going to change the position of the player here. Okay, so initially we can type here transform dot position plus equals vector3 dot forward multiplied by speed multiplied by time dot delta time. So if we save this and we wait for the compilation to be complete, and if we press the play button, okay, we can still move to the left, to the right, we can still press space to jump, but if you press the up key, then the player is moving forward. Okay, this is great. Now, if we go back here, okay, into the game, we want to make the player to use the right and the left keys for rotation. Okay, so we need to determine the rotation speed. So we're going to remove this logic that we wrote to move to the left and to the right to replace it for something else. Okay, so we're going to type here public float rotating speed. Let's set that to be like 40f. Okay, and when we press the right key, we're going to type here transform dot position, and then we're going to type actually transform dot rotate around. This is going to be a method call. Okay, we access the transform component and we call the rotate around method, so as the name suggests, we rotate it around somewhere. Okay, so we need to pass three parameters here: the point to be considered for the rotation, the axis, and the angle. Okay, so the point is going to be the exact place where the player is standing, and we can get this by typing transform.position. The second value is the axis that is going to be used for rotating the player around. So what we want to do is rotate the player like I'm going to show you right now. It's going to rotate like this, okay, to the left and to the right. And if you look at the inspector in the transform component, notice that the only value that changes is the vertical one. So we are rotating around the vertical axis. And to do this, we type vector3.up. And the third parameter is the angle. Okay, how much is going to be rotated? As we are in the update method, we're going to type rotating speed multiplied by time to delta time. For the same reason we do the delta time trick in the horizontal movement. Okay, so if we save this and go back to Unity and wait for this compilation to be complete, we're going to press the play button one more time. So we have our player here, we move left, but if we press the right key, then the player is rotating to the right. Okay, we do the same thing for the left button. We type transform.rotate around. The parameters are going to be transform.position, vector3.up, and this time, instead of just typing rotating speed multiplied by time.delta time, we're going to type minus rotating speed multiplied by time.delta time. okay, and finish this line here. So now with these two instructions, with these two modifications, we can already make our player move to the left and to the right, okay. And after this is complete, we would expect the player, well, to follow the direction that we are moving. But if we press up, the player is still moving forward until it falls completely, and well, we can't access the player anymore. So what do we need to do? We need to get the forward vector of the player. Okay, so you might have thought in the beginning that this would work out of the box, but the thing is, here when we get key up, we type transform.position plus equals vector3.forward. Vector3.forward is a constant. It's always going to be 0 on x, 0 on y, and 1 on z. So this doesn't change even if the player rotates to different positions. Okay, this is a constant. So we would have to implement some complex mathematics here, or we can just get the player's angle and then perform some trigonometry, but there is a very easy way to do this. Instead of typing vector3.forward, we can just type transform.forward. So Unity makes our lives much easier by doing this. Okay, we access the transform component, we type dot, and we get forward. Okay, so as you see in the summary, this is the blue axis of the transform in the world space. So this is going to change if you rotate to whatever position you want. If you rotate to the left, the forward is going to rotate accordingly. And remember, this is a direction. Even though it's a vector 3, it still works as an arrow that is pointing somewhere. It's the same way. Okay, the size is 1. Okay, if you multiply it by speed, you're going to scale in the direction that you're looking. And if you keep pressing up, the player is going to keep moving. So if we save this and go to Unity and wait for this compilation to complete, we're going to press the play button. We have our player falling here. We can rotate around, and this time if we press the up button, then the cube is falling to whatever direction we are looking at. Okay, so we can increase this rotating speed to 90, I think. Yeah, much better. So we can make the cube move like this. Okay, even more, maybe 140. Yes, this is good. Okay, so we have a cube that is moving at different speeds. We can rotate it around, and this is a very interesting concept if you want to make virtual reality games. Okay, you're going to see that this is going to help you a lot. You pretty much use this on nearly all virtual reality games. Okay, let's just save this value here. And now that we have this, let's say we want to use multiple cameras for this game, okay, or multiple rendering modes, because right now it's a bit difficult to follow this player. So what we can do is to just get this camera and move it up a little bit. Okay, maybe rotate it down a few degrees. Okay, so it looks like this. It's probably better to see the player. But what if you want to change different cameras in the game? What if you want to cycle in different cameras in here? We're going to use the mouse button for this. We're going to listen if we are pressing the mouse button, and if we're doing this, we're going to rotate among all the available cameras. So we're going to do this in the next video. Okay, so let's continue our little experiment here. Right now we have only one camera. Okay, it's pointing to this cube here. The player can move around. But what if we want to have multiple cameras so we can cycle between them? Okay, we're going to need to use our game controller to help us doing this logic. Okay, so first of all, let's move this main camera inside the game controller in the hierarchy. Okay, we can even move this game controller up. So the main camera is now inside that controller. And we want to have more cameras in here. Okay, so here we just have one. If we want another one, we can just go here and right click in this main camera and select duplicate. So we now have another camera. You can see main camera 1. And then we can move this camera to another position. Okay, so we can change it to -6 on X, 0 on Z, and we can change its rotation in the vertical axis to 90. So it's facing our player in another side. Okay, and you can notice in the camera preview that we now focus on the first camera. But the logic that we want to do is we are going to disable all the cameras but one, which is going to be the active one. So for instance, if we want the first camera to be available, we're going to disable the second, okay, and the first camera is going to be focused. That's pretty much the game that we're going to do here. Okay, and if you look at the camera preview and you swap the cameras that are focused in the hierarchy, you can even see all of these previews. So we can add a third camera here, Okay, and maybe make this a more vertical view. So maybe we change X to 0. On Y we can use 0 as well, and the rotation on X can be 90. Okay, so let's make this to be in the vertical position 10. Okay, so we have this camera, this one, okay, this, and this, and maybe we want to add a third one that is going to be a bit closer to the player, but it's going to follow it. So let's let me see, let's duplicate this one and move it here and then here. Okay, let's change its rotation to 45, okay, maybe 50. Okay, and what I'm doing here is basically experiment. You can put your cameras in whatever positions you want. Okay, just this is basically just for testing. Okay, you can find the exact values that you want here. You don't need to be exactly what I'm putting here. I'm just trying some random values and random positions to make something like this. Okay, so it's going to look cool. Now we need to move back to the game controller. Okay, let's remove this hello world string. I think we said hello to world a few times. And now we need to have a reference to all of our cameras. Okay, we have 4 right here. There are several ways to do this, but let's work on a way that is more transparent. We're going to type in the beginning of the class public game object. We're going to open and close these brackets, and we're going to type cameras. Okay, or let's use game cameras just so we don't have a conflict of names here. And why the brackets? The brackets are a way for defining that the thing that we're going to store in the game cameras variable is going to be an array of game object. So there are going to be multiple game objects that are going to be stored in this variable. And in the editor, you see that game cameras is a bit different than the other ones. Okay, so if you look at the player, speed, rotating speed, and jumping force, they all have a text field, so you can put the number that you want here. But if you look at the game controller, you see game cameras it contains kind of a hierarchy inside it. So you click on this arrow to open it, and we can change the number in size to 4. So we have now 4 slots to position our cameras. So what we're going to do is simply drag and drop all of them and position them in these slots. Okay, so slot 1, slot 2, slot 3, and finally slot 4. Okay, so all of them are located here. Okay, so you have all the 4 cameras working just fine. However, if we play the game, all of the 4 cameras are going to be enabled. Okay, you can even see that sometimes you receive a warning, a kind of a log message in the console that there are 4 audio listeners in the scene. Okay, because all of the 4 cameras, they can listen for audio, which is not a desired behavior. Okay, but anyway, we have to work on our logic to select only 1 camera. So to do this, we need the help of one variable. We're going to type here private int game camera index, and we start that as 0. Okay, so why index? The index that we're going to use here, this number, is kind of going to point to the camera that we want to use. Okay, so game cameras contain 4 cameras, and all of these cameras, they can be accessed in the indexes 0, 1, 2, and 3. So we want to cycle among this. We are on 0. If we press the mouse button, we go to 1. If we press it again, we go to 2, and then it's going to keep moving like that. And we can move them both ways. Okay, we can use the left or the right mouse buttons. So now we want to make a method here. Okay, we want to make a method called void focus on camera. Okay, and this is going to receive an int index. Okay, and we open and close curly braces. So what did we do here? Focus on camera is going to receive an index that is going to vary from 1 to 3, so 0, 1, 2, 3, and we're going to disable all the cameras except the one described in this index. And to do this, this is what we have to type: for int I equals to 0, semicolon, I lesser than game cameras dot length, semicolon, I plus plus, then we can close parentheses and then open and close curly braces. So we're making a very simple loop here. And this I is going to vary from 0 to 3, okay, because this is what we get when we use I lesser than game cameras dot length, which is 4. Okay, so this is going to loop in 0, 1, 2, and 3. Okay, so what we want to do here is type game cameras, and we type this, we open brackets and we pass I, close brackets, and all of this dot set active. And we need to put a condition here that is going to say if this camera is going to be active or not. it's only going to be active if I equals to index. Okay, if it isn't, if it's different, that means that is not the camera that we want to use, and it's going to be disabled. So in the start method, we can type focus on camera, and let's pass game camera index as a parameter, okay, which is the variable that we have here. If we save this and go to Unity and wait for this compilation to complete, okay, let's also clear our console and select collapse. If we press play, notice it's a bit difficult to see, but if you look at the game controller, main camera text is black, but the other ones are grayed out because we have only one available camera, and it is the one that we had available since the beginning of this lesson. Okay, it's the original camera. And now we want to cycle in these other cameras. So how do we do this? We want to make a new method here. So we're going to use void change camera. Okay, and we want to pass here a int direction. Okay, so why direction? This direction variable here is going to be either 1 or -1, because this is going to be the delta for the index. We're going to increase or decrease the game camera index by a certain value. Okay, so what we want to do is this. We're going to type game camera index plus equals direction. But now we need to make a few verifications here. We need to check if game camera index is greater or equal than game cameras dot length. Why this? Okay, so remember, game cameras dot length is going to return 4 because we have 4 cameras, but the available indexes start from 0, so we have 0, 1, 2, 3. So if game camera index reaches 4 or greater, it means that it needs to go back to 0, so we're going to do a cycle. So we type game camera index equals to 0. However, we need to check for something else. If direction is a negative value, if you are moving back, we need to check if game camera index is lesser than 0, because that's an invalid number for an index. It can't be negative. So we need to check if game camera index is lesser or equal than 0. Then what we have to do is set game camera index to be game cameras dot length -1. Okay, because this is 4 a -1 is going to be 3, which is a valid position. So this is what we do to change the camera. And finally, after this, we're going to type focus on camera game camera index. Okay, so that's basically it. And now we need to actually call the change camera method. And to do this, we're going to listen from some mouse inputs. You could listen for other keys if you want, but let's try another input here, another input way. We're going to type if input.get mouse button, and you notice that you have get mouse button and you have get mouse button down. It works the exact same way when you're pressing buttons. Okay, down is going to return true in the exact frame where the mouse button is being held down, and false on the other ways until you release the mouse and then press it again. So here we're going to use get mouse button down 0. Okay, so this is the left mouse button. Now we close the parentheses, we open and close curly braces, and here we're going to type change camera, and we're going to pass 1 as a parameter. So we're going to cycle the cameras to the right. If we save this and go to Unity and wait for this compilation to complete, we're now going to press the play button. So we have our cube here, it's moving how it was moving before. If we press the mouse button, then we change for another camera, so we have another vision of what's happening here. If we press it again, we move to the top camera, so we can see the cube like this. And if we press it one more time, we have this other camera here, okay, that is in this position. And if we press one last time, notice that it's not cycling just yet. Okay, I'm in the last one, I press the mouse button, but it's still not moving, so we have to check what's wrong with this. So let's see, game camera index is 3 here. Okay, well, the reason is we have here if game camera index is lesser or equal than 0. We just have to check if it's lesser than 0, if it's negative, okay, not equal, because what was happening here is we were on the last camera, we set game camera index to be 0, and then we entered this condition because it was lesser or equal than 0. Then we moved the game camera index to be the last index, okay, right away. So it is interesting that this happened, so you can see how sometimes a very small detail can change how it works. So now if we press 3 times, then another one, then we move back to the other cameras. Okay, so we can cycle through all of our 4 cameras. But what if we press the right mouse button? Okay, we can type here if input dot get mouse button down, and then we pass 1 as a parameter. Let's type change camera and pass -1 as a parameter. Okay, we can save this, go to Unity, wait for the compilation to happen, then we press the play button. Okay, then we can cycle normally, but if we press the right one, we move backwards. If we keep cycling with the left and right mouse button, we are going to cycle through the same two cameras, and then we can, well, move to any direction that we want. Okay, like this. And now, just to add a very small effect, let's change these last camera. Let's make this camera to look at our player. Okay, just so it's going to give a different sense of what's happening here. So we're going to make a new script in the project window. So right click, select create, then C# script. This is going to be named chase camera. Okay, we can hit enter and wait for this to compile. And in main camera 3, we're going to drag this chase camera script and drop in main camera 3. Okay, now we open chase camera, and we need to set the target for the chase camera. So we can type here public transform target. And in the update method, we're going to type transform.lookAt, and the parameter is going to be the target. So we pass target as a parameter. Okay. So we save this, go to Unity, let's wait for this compilation to complete, and in the chase camera there's going to be this target position, and we just drag and drop the player in here. Okay, so we access the player transform component, and the third camera is going to look at it. Okay, so we have the first one, the second, the third, and the fourth. Okay, and if we move our player, the camera is going to basically follow our player. Okay, so that's it for this video. Okay, I hope you enjoyed this. We tried to make this a bit more fun by using the input on real life scenarios. Okay, you're going to use this a lot. You can make this system for cycling between cameras, and you can make a player that can basically walk around, move, and look at any direction. And this is going to be very useful if you're making other games like virtual reality ones, and well, pretty much any game that receives any sort of input. Okay. My name is Glauco Pires, thank you very much for watching, and I'll see you next time. Goodbye.